Good afternoon, everyone, and welcome to Future Plymouth 2030. This webinar is about standards for better performing buildings, and we'll be talking all about zero carbon, net zero, and Passivhaus. We have three fantastic guests for you this afternoon. We have Professor de Wilde from Plymouth University and CIBSE. We also have Kate Fry, who's Principal Engineer from CDS. And we also have Andrew Nash from Kier Construction. My name is Miles Noble, and I'll be taking you through the webinar this afternoon. At the end of the webinar, there will be a Q&A session, so please stick around for that, and you can have your chance to ask your questions directly to the panel. But if you would like to put your question forward during the webinar, please click the Q&A button at the bottom of the screen. So without any further ado, I'd just like to introduce you to Professor de Wilde from the University and for his talk. Over to you, Peter.
Okay, can you hear me?
Yes.
Okay, let's pull up my slides. Okay, so thank you, Miles, for the introduction, and welcome everyone. Thanks for having me today to talk to you. Like introduced, my name is Pieter de Wilde, originally from the Netherlands. That explains the accent, but I've been at Plymouth for 15 years now. And I'm going to talk about high performance buildings. I do that on behalf of the university, where I'm in the School of Art, Design and Architecture in the Built Environment group. I also represent the Sustainable Earth Institute, one of the groups at the university that brings together people that have interest in sustainability. And I also wear a third hat as representative of CIBSE Southwest, specifically the Peninsula Committee. The outline of today is I'll be talking about high performance buildings, but I'll sketch you a little bit the landscape that we're taking. So I want to position that topic of high performance buildings in a slightly wider frame of many of the terms that you come across when you talk about the type of building. I will then dig a bit deeper on what building performance is typically seen to be, talk a bit about how we can move on with that, and also talk about the complexity that we face in doing that. So things like the life cycle, the stakeholders, all the systems, and the external pressures that we're actually trying to respond to. I will then make a bit of a difference between legislation, rating systems, and what I call the engineering view, and give you some pointers to some work that we do at the university and pathways if you want to know more about these things, where you can learn about these things. I'll end up with take-home points and open up the Q&A. So set you in the scene for the back there. So high-performance buildings. What's in a name? Well, we have an image here of the Smeaton Tower on the screen, and in a way that is a high-performance building. That is a building that is, especially when it was still out on the Eddystone Reef, exposed to quite extreme conditions. So it has some implications in there. But then we come across a range of other names. So things like eco buildings, passive house, zero energy house, or plus energy house, or we can talk about net zero emission or net zero carbon, autarkic house. Then we have the BREEAM and the LEED certified buildings, green buildings, sustainable buildings. It is a very long list. Yeah? And all these things, they kind of imply specific focus areas. And there's quite a bit of uncertainty often amongst my students about what is what and how we draw the boundaries between those things. So if we talk about high performance buildings and building performance, then the dominant view of that seems to be one that somehow relates to sustainability, energy efficiency, and thermal comfort. The building you see on the screen is actually a shot taken from the High Performance Building magazine from our friends at ASHRAE, that is the American counterpart to CIBSE. And they have this magazine about high performance buildings, and what you see is a lot of buildings that feature all these typical things that we associate with building performance. So things like daylighting, natural ventilation, use of renewable sources, water conservation. And because it's an American building, it's all normalized into US dollars, and what they're proud of here is an energy cost that is $0 per square foot. So that is something we see a lot when we talk about building performance. And if we have the discussion within our groups at CIBSE or at the university, then a lot of that boils down to energy efficiency and things like the certification scheme. So you all know these things that we see on the white goods, but we also have them in buildings now, and we have long discussions about what the energy performance certificate is and what the display certificate is and whether there's a gap between the two. So that is where a lot of the focus of our work goes. CIBSE also run a building performance award, and again it tends to focus in this area. Now if we look at the background of building performance, actually building performance has been in the interest of humanity for a much longer time. That's not a recent phenomenon. If you go to the very first buildings you built, that is about creating shelter against the environment. And of course, people are interested in which building keeps you better dry or keeps the animals out more safely than another building. So that has always been in there. But originally, all of that kind of goes into a concept where architects and other people work together. There's the concept of the master builder, and originally that's one person that's in charge of everything. And we have this evolution of design and the craft of building houses over the years, and performance is part of that. Performance actually comes to a specific realm of its own already very early on. So if you look at the time frame of performance things that are on my timeline over there, very early on you have the Hammurabi Code, which is 1700 years before Christmas in Persia, where actually there's a law that says if a builder constructs a building and that building falls down and kills the occupants, then that builder shall be put to death. Very strong statement about building performance, what the building has to do, and also the very harsh consequences if you fail to meet that performance standard. So that's a warning. If we complain about Part L regulation, it's been worse in the past. Over the years, then kind of things mumble along and we make nice buildings, but then we have things like the Great Fire of London in 1666, where suddenly people are confronted with a performance issue and actually decide they need to take action on that. And that is where we see a lot of the regulation and safety coming into place. Then we have another thing where things branch off, and that is the Industrial Revolution. So until then, we have these master builders where everything is in one person. And then suddenly you see the emergence of, first of all, structural engineering, then mechanical engineering, CIBSE is founded, and the performance then kind of branches off amongst the different specialties. Of course, then there is increasing specification, and so around 1970, when I actually was born, we get building performance as a discipline in itself, so no longer as part of the building services engineering, but it becomes a field where people actually have a research group at the University in Scotland, the Building Performance Research Unit at Strathclyde, and there's books and there's work in this area that kind of distinguishes this as a field in itself. Now, like I said, the initial take of most people is to say building performance is strongly related to energy, thermal comfort, maybe a bit of structural lighting, ventilation. But one of the things that I really try to champion with my students over the years is that there's many more. I did a quite intensive research on what aspects are in there. I can reach behind me and grab my thick book that I wrote on building performance. And one of the things you find in that book is an appendix that lists almost 80 different things that we should be looking at when we talk about buildings. So, for instance, it has to do with olfactory comfort, what you smell in the building, or it has to do with burglary protection, or how you can find your way in the building, or how you keep vermin or pests out of building. All these are things that we can measure and that actually have to do with performance of buildings. So we should not forget those. But all of this then also brings us to quite a bit of complexity. So one of the first things is you have so many aspects on the table, then it's all like a spider's web. If you draw on one side, everything starts to move and everything is interconnected. So if you make buildings more energy efficient, then that might have consequences for, let's say, the fire safety on the other end. And if we think of Grenfell, an effort to make a building more sustainable and more energy efficient later on had very nasty consequences in terms of safety of the occupants in there. And in fact, that spider web, every string you touch is related to the others. Then we have to deal with other complexities, and I'll talk a little bit about that on the next couple of slides, but we have a long life cycle, coping with different scenarios. We have very many stakeholders in the project, quite a lot of factors that we try to respond to. And then we have these regulations, and we need to deal with those and make sure that we handle them right. Now, life cycle. I always like to show this image of this high performance building we have on the left here. Yeah, most buildings are around for, let's say, 50 to 100 years. And that is extremely long if I compare that to, for instance, the lifetime of this little gadget that I always carry around. Yeah, mobile phone, typically 2-3 years, and then we're up to the shop to buy our new one. Buildings are around for a longer time, and that poses challenges. So if you think about something like climate change and a warming situation, more extreme weather events, our buildings are likely to face that, and that makes our design, our engineering more complex. We then also have to take into account that if we try to do that engineering and design for the future, then we have to deal with things like facility management, renovation and retrofit. And these are all things that happen throughout that long lifetime, but also are hard to predict. It's very hard to say right now, if you build a building, let's say on the university campus, to predict what the facility management, how good that will be in 20 years down the line? And when can we expect the renovation? When can we expect the retrofit and a new heating system to be brought in? Makes it difficult to do our job. At the same time, so the high performance building of Stonehenge, I like to show that to my students and challenge them to say, okay, you design a building that is supposed to last for 3,000 years, and you design a system to bring in stones from Wales to make a monument in Wiltshire and actually have something that is related to where the solar position is. That is a nice challenge. But if we don't get it right, you get this building which was on Plymouth Road toward Tavistock for a couple of years. Yeah? If you don't have the maintenance in place and you don't have the retrofit, then after a while buildings start to degrade and we really lose functionality. Then we have the complexity of the stakeholders. So there's a lot to be said about the different people that are involved. And if you work in the industry, like probably most people on this call today do, we have to deal with a whole range of people. So the client, the design team, the contractor, the occupants later on in the building. That is already complex, and we need to take care of all of them and make sure that there's good communication. But then if we start thinking in more detail about that, then actually you start to realize that for a building like a university building, the tenant is actually an organization with a whole range of people in there. So there's a dean, there's a head of school, there's a head of department, there's a secretary, there's a large number of staff, there's a large number of students. So that becomes a complex organization in itself. And the communication from that organization with, let's say, the architect and the engineers that develop the new building is a specialty in itself. There's also risks in this. So the more you read about that and you follow the news, the more you see that stereotyping is something difficult. And that happens all the time. And especially if we say, well, this is the way an architect thinks, this is the way an engineer thinks, then actually we're kind of fooling ourselves and often making mistakes. An example I like to talk to my students about is, for instance, Calatrava, who's done some very nice building design. I like the railway station in Liège in Belgium, which he designed. And it's really on the interface between structural engineering, architecture, and actually, in a way, sculpture in itself. Yeah, so all those boundaries then kind of become difficult, and we need to look into that. Then we face a challenge because our industry has a multitude of systems and components. If you think what goes into a building, there's the suite catalog with thousands of systems that go into buildings. That is already complex in itself. If we look at all those systems and parts that go into building, you can say that many of them even have a longer list of subcomponents. So if I take, for instance, something like a heat pump or a boiler, that again consists of a whole range of parts and elements that go in there. And you can have endless discussion on what is a system, what is a subsystem, what is a component, what is an element. But in a way, we need to bring it all together to create our buildings. What makes it more complex is that in most industries, there typically is one dominant technology. So if you think about aircraft design, typically that is a metal or a composite tube with two wings, two tailplanes, one vertical stabilizer, two engines under the wings, and that is the dominant design. And a lot of that is in the same technology. We build buildings in concrete, in steel, in wood, sometimes from straw bale, sometimes from cob. And even worse, we mix those technologies and then we like to change them. Yeah? So there's nobody who has a car and suddenly decides, you know, I have a 4-door car and let's make it into a 6-door car and install an extra rear axle and an extra engine. In buildings, that is pretty common to do that and change later on. Then we have the effect that we like to improve our buildings, and high performance buildings is one of those areas where people also like to experiment with novel technologies. So things like vacuum insulation panels or you name it. All of those systems are interesting and we like to work with them, but they also have their challenges in that they often are new technologies and need to ripen. So we take a risk by using them in our buildings. Then we have our external drivers. And I've had for a long time discussions with colleagues where I remember some heated debates that climate change was seen to be the major driver that we need to respond to. And in a way, that is true. But in another way, it's not true. So the current situation with the pandemic suddenly puts climate change into a different category, and everybody's now focusing on how we cope with COVID-19 in our buildings. Might be if the vaccine works that we can go back to worrying about climate change. There's also people that actually see some connection between what we do to the wider environment and the emergence of things like COVID, but it's a different challenge for buildings. I like to point at some other of the challenges that we have in there. So climate change, warming situation, and more extreme events is something that I researched in the past, and that's definitely an important one to look at. But there's other stuff, yeah? So for instance, peak oil. If we keep using fossil fuels, then long before we get out of fossil fuels and we don't have any left, the price goes up. And that is an effect that we will see much earlier than us running out of fossil fuels. One to think about. Clean water is becoming more and more of a problem. University has done quite a bit of work on microplastics in water and all the health effects that might have. Yeah, it's another one to worry about. And what the construction does in that sense is something that we should explore. Local ecosystems. So I like to show that image of the Deepwater Horizon, and you can have the nasty images next to that of birds drenched in oil. That type of thing is a different effect from climate change, but it's something we do to the environment. And if we construct buildings, we need to think about that. This work that's happening in, let's say, the Amazon, where the forest is taken away to produce materials sometimes that are used in construction, is something we need to worry about. Material scarcity in general. Then we have population growth and how we deal with that. And there's difficult trends there. And one of the examples is renewable energy is a good thing, but at some point we can only use a field once. We can use it to put photovoltaic arrays there, or we can produce food. And if the trends continue, then we have a challenge there. Then we have economical developments. Yeah? So in the end, construction is an industry, and we are part of that economic cycle, and we are important to make sure that our nations do well. And finally, there's technological change. And I think we are also in the position that if everybody has all these electronic gadgets and is in full control of a lot of things, then our buildings become actually quite simple, obsolete technology structures with very outdated technology in there. So the NIST thermostat might look fancy on the wall, but it's still in essence almost a turning knob. And we need to look at what we can do to catch up and have the same experience that people get, for instance, when they step into their car. So quite a lot of pressures that we deal with. Now, if we then take that into how that sits in the industry, and hopefully the next two speakers will follow up on some of this. But we start, of course, with building regulations, where the government tells us that every building needs at least a certain lowest level of performance. What is interesting if you look at building regulations is that originally building regulations gave a list of solutions. So if you were to build in a certain way, if you make a detail as specified by the government, you are okay to build. In the 1980s, there was quite a bit of discussion where people wanted to move from what is called prescriptive regulations to performance-based regulations. Performance-based regulations lets go of saying this is the good solution. If you do this, you're okay. It just says if you build a building, for instance, you should make sure that your energy use per square meter is not higher than a certain threshold. And how you actually achieve that, we leave completely open to the designer. As long as you meet the performance, you're good. That was interesting, and there was a lot of work, for instance, in the CIB, the International Building Society, to get that to be adapted across the world. But then you find out that for some areas, it doesn't work as easy as that. So the full swing to completely performance-based regulation has never happened. What you see in practice is typically a mix where some of the regulation, like the energy efficiency, is performance-based, but there's other areas where we still prescribe solutions because that works. One thing to keep in mind if you talk about regulation is that regulation is something that needs to stand up in court. So this needs to be a black and white approach. You need to be able to say, if you designed the building, did it meet the regulations, yes or no? And you go back to an example like Grenfell Tower. Yeah, people at the moment can go into court and you can say, can we blame the architect? Did he do a good design? Can we blame the consultant? Did they do a good job? How about the contractor? Did they meet the specifications? It needs to be black and white. And that is what's always there in a legal context. One of the things you get into if you look at all these legal documents is also, it is something that does your head in. So I'm a performance in building and a professor in building performance analysis. It's my job to look at these things. So one of the things I did about a year ago was go into the university system and download all the building norms that I could get my hand on. And we have a system called the Construction Information System, where you can get all the British standard, England and ISO norms and download them to your machine, and you can start reading. I never got much further than making a spreadsheet that has the names and the codes of these norms. And then, well, as you see, this screen ends at 1200 something, and that's just in the middle of my spreadsheet. Yeah, there's a long, long range of codes and norms that applies to buildings. So actually getting all of that to be integrated in a design and meeting all those regulations that are out there, that is a really steep uphill challenge. Then beyond that, we have voluntary rating schemes. So you might all know BREEAM, the Building Research Establishment Environment method, but there's others around there, right? So the US has LEED, we have Passivhaus. I think there's a talk on Passivhaus later on. One of the new kids on the block is WELL, which is more on the health effect, but we've got things from further afield. Yeah, so we have in Qatar the GSAS system, the Global Sustainability Assessment Scheme. We have CASPI in China and Japan. We have Menergy in Switzerland. We have neighbors in Australia, and that list goes on. Typically, those voluntary rating schemes, they're really driven by the industry, and they help to increase sales and prestige. Yeah? So if you can say my building is LEED Gold certified or LEED Platinum or BREEAM Excellent, that is an argument that allows you to set the building into the market and claim some brownie points. If you look in more detail in how you achieve that rating, then typically all those rating schemes are based on gaining some points, getting some credits. And some of those credits are related to performance, but there might also be points for things that are actually not related to building performance. And that is where things start to diverge from what, in my perception, is a high performance building. So for instance, you can, in many schemes, get extra points for using a certified assessor in your design process. That says something about the process, but not about the building. Sometimes you can get credits for being close to the railway station, for having a bicycle shed. That's not necessarily a building performance thing. That's just something that you can score, right? Again, because this is a rating scheme, people will want to know black and white whether they meet the criteria and are in line for your silver or your gold award or your excellent or your pass rate. Yeah, so we need, again, a normative method that's decide whether you're in or whether you're out into that category. Needs to be black and white. Then we have the engineering perspective. And if we do engineering, then typically we are aware that there's uncertainties and we predict things, but typically with an error margin. This also leads us to wanting to say, well, all this stuff, all these aspects, so Peter, you talk about 80 different performance aspects. How do we handle that? Well, the first thing is that we need to be able to measure it. Yeah, so we have the quotation of our famous Lord Kelvin in here. If you cannot measure it, you cannot improve it. So if I want to do high performance, then first of all, I should measure performance and then be able to say, am I in the high performance bracket, yes or no? But that leaves us to further problems, because then we need to define performance, and that's not an easy one. We also need to talk about how we can measure it. And then we need to decide in a design process or a re-engineering process how we can improve the performance. Not easy things. If you're interested in that, I will just point to the masters we have and where we talk a lot about these things. But here I will just keep it relatively simple. And I will say, okay, performance is something that has to do with how well the building does the functions that it has. So it needs to be energy efficient. It needs to provide fire safety. And how well the building does that, we can actually measure that with 4 main approaches. The first is the good old physical measurement. Think about Newton and the apple, and we measure how quickly it falls and what forces is in there. And we can use that on buildings as well and do measurements. Problem we have is that buildings are large and expensive, and bringing a building into the lab is something that we actually only do for components, right? Nobody takes a full Grenfell tower into a fire lab. Maybe a part of the facade, but not the whole thing. So for measurement, we're often looking at buildings in their context, but that means that we have not full control. So we don't have full control about the climate, we don't have full control about the occupants. The second approach we have to quantify performance is computer simulation. That's where we build a good model in our nice computers that we all have, and we try to predict how performance would be, assuming that we make no errors in physics, the math, and in the coding. Yeah? If we do it all right, then we can actually look at all kinds of variants in the building, compare them under identical scenarios, which is great. And we can also predict performance of buildings that have not been designed yet, which is also a good thing. Then there's 2 more categories, and these often are overlooked. So the first one is expert judgment. That is actually a way of looking at performance where people that have been in the field are asked to make an opinion, and mostly people that have worked in this area can come to a pretty good conclusion on that. Especially in cases of law, we often see this where you have actually expert judgments coming into a court case and give an opinion based on a track record and being an impartial judge on that. The final one then is stakeholder evaluation, and that is also often called occupancy surveys. This is related to the idea that in the end, whether a building works or not, whether it performs well or not, is to be judged by the client. Client is king, so let's ask the occupant what is in there. That is a very useful approach, typically done under the banner of post-occupancy evaluation. But one of the problems we have there is that the judgment of people often is subjective and has noise in there. So when I ask my students whether their room is comfortable, if I do that in September when they just start the new lecture term and they're all excited and they're in a good mood and they just come from holiday, then we'll have a different perception than when I ask them at the end of term when the exam is near and they're all stressed out. The conditions in the room might be the same, but what they make of that building might be dependent on external stressors. So that is one of the complexities we have in that field. So like I said, building performance, something we want to measure, but then what is high performance is where we actually take a building and compare that to other buildings, to the peers. Yeah, that's one of the things, but we also need to look at what experiment or what loading we have on that building. So the same building positioned in the relatively mild maritime climate of Plymouth, if I take that same building and put it in the top of Scandinavia where there's a much harder winter, then that same building will have to work harder to maintain a thermal comfort in the winter conditions. So we also need to take that into account. If we look at how that building performs related to the peers, then that instantly also means that if we have high performance buildings, then we probably also have low performance buildings, something that is not so good. And we probably need to look at those. And there might also be a middle group of regularly performing buildings. Yeah? Where you actually draw those lines is something that has not been debated in industry as far as I can find. But you can have a discussion whether high performance building is your top half, your top quarter, or just your top 10. Yeah, and that has to do with where we want to drive those boundaries. It's also at odds with things like rating systems, because in a rating system, in theory, once you've defined what a BREEAM Gold building is, all buildings in the world could do that and all be in line for a BREEAM Gold award. Then that would reduce the usefulness to the people that built those buildings. But because it's a normative system, once you've drawn the boundary, it's in or out. For high performance building, that is not defined that way. Yeah? So one example, and I note, sorry that these sub slides do not come in. One of the buildings at the university that's actually trying to do this is the Sustainability Hub, Low Carbon Devon project. And this is done by my colleagues in the Sustainable Earth Institute. And let's see whether something comes up, but it looks like I'm losing some text. No, oh, that's good, it's coming in, it's just one by one. That's what you get, a slide from colleagues. Yeah, but this is a demo project that actually has ambitions, and you could make a case that this is a high performance buildings. And this is one of the things that people are working on within the university at the moment. And if you want to be involved, there's a questionnaire, and colleagues in this field are really keen to get in touch with you. At the university, we also do other stuff. So we have an MSc that has exactly the title of my talk. So Master in High Performance Buildings, that is accredited by CIBSE. So that's my CIBSE hat on, as well as my university hat. And this is really where we go deeper into all these things. So if you want to learn about high performance buildings, then that is one of the things that is in there. And that's why we have this image of a building on Antarctica that's actually subject to a balmy -10 degrees in the summer and goes all the way to -50 in the winter, and where the wind throws rocks at it in the winter night situation. Yeah? So different concept of performance. If you're interested in that, feel free to also drop me an email. Then if you're more into reading, there's my book on building performance analysis, published 2 years ago, but that's 600 pages on this subject. So if you want to delve deeper on that, it's quite a bit more to say. And so 25 minutes talk is really just to skim on the high level. Okay, so I'm going to round up, and I see that it's slightly overrun, so it's time to do that. Couple of things to keep in mind. So high performance buildings, mind the terminology and the definitions, and be careful, and especially also if you use the other terms. Mind the many performance aspects that are there, handle the complexity, differentiate between regulations, voluntary schemes, and the engineering view, and keep in mind that there's this normative and those that allow to handle uncertainty. And keep in mind, there's a lot more to be said about these things. So that's why we teach this at university level. And I think I leave it at that and hand it back to Miles. Thank you, Miles. And thank everybody else for attending.
Thank you very much, Peter. That was a really great presentation. Thank you very much for taking time out today. Maybe if you could post your a link to your book in the chat, I think people would be really interested to have a look at that as well. Next up, we have Kate Fry, and she's Principal Engineer from CDS. Over to you, Kate.
Hi, there we are. Thanks, Miles. Sorry, trying to deal with all the technology. Can you see my screen?
Yes, all good. All good.
Lovely, fantastic. So my name's Kate Fry. I'm a principal mechanical engineer at SDS. We're based in Plymouth, and we're building service engineers. I'm also on the Peninsula CIBSE Southwest Committee. Today I'm going to be talking about quite a specific subject on the effects of grid decarbonisation on our building services design. There we go. So what I'm going to talk about today is basically what decarbonisation is. Then I'm going to talk a little bit about building compliance, which Peter has covered a little bit in his presentation. Then go on to low carbon building design, a few domestic comparisons in our domestic builds. So this is essentially why we're moving away from gas and direct electric heating, and what we're moving on to in the future. Then going to discuss some limitations with our current regulations and current designs. And then end on a bit of a more positive note after limitations on the Green Industrial Revolution. This is the government's new 10-point scheme they came out with in November. And then just end with a zero carbon example, how we're working towards zero carbon buildings. So the first point here is decarbonisation. What is decarbonisation? So it's the idea of reducing the carbon emission factor of the grid. So this is the amount of CO2 emissions per kilowatt hour of energy produced by the grid. And as you can see on the graph on the left, this is dropping over the years. So the dotted line is what they estimated in 2017, and then they re-estimated it again in 2018, and you can see it dropped even further. Unfortunately, I don't have any more up-to-date values on this. But what it is worth noting on here is in 2018, we had a grid emission factor of 0.17 kilograms of CO2 per kilowatt hour. And I'll come back to that later in the slide. But essentially this is dropping, and the reasons this is dropping is because of the way our grid technologies are changing. So as you can see in the graph there on the left, we can see that natural gas has had a few dips and is changing over the years, but the huge differences are coming with the coal and with the renewables, how that's changing. So in 2020, we had a huge 34% coming from renewable technology into the grid, 20% nuclear. We had a huge reduction of oil and gas down at 37. And what was really interesting this year is during the first COVID lockdown, so that was March to June, I think it was, there was 0% coal usage feeding into the grid. And that's the first time since forever that that's happened. But we are unfortunately now back to using coal as the demand has increased since the lockdown. There are some other technologies being used in the grid, pumped storage, interconnectors, which is essentially energy from abroad, and carbon capture, which is a big buzzword at the moment, which essentially is capturing that CO2 so it doesn't go to atmosphere, and then even further decarbonising the grid. Right, so I'm just going to head off from decarbonisation for a bit and talk to you about building compliance, part L, which some of you might be very familiar with. And there is one big problem with the way the current building compliance assessments are simulated. We are using a document called SAP 2012, which is our current regulation. And that was quite a long time ago. And as you can see here, the grid electricity carbon factor that we are using in SAP 2012 is 0.159. And as we saw from the previous slide, this is actually more like 0.17. So there's a huge gap between what we should be using and what we are currently using. However, SAP 2019, which is due to come out in spring 2021, so only 2 years late, hopefully it does come out then, because the grid electricity carbon factor will then be going down, they've predicted, to 0.136. And as you can see, this will change massively how we view gas and electricity in our buildings, and the way they affect the low carbonness of our buildings. You see also that the mains gas carbon emission is dropping slightly, and that's probably due with the increased efficiency on transmission. Right, so I'm just going to talk a little bit about low carbon design and how we actually go through like 3 steps for a low carbon design building. So number 1 is fabric energy efficiency. So this is reducing the energy demand in our building. And this is very much a fabric first approach, which is what we like to do. Before we start adding any other technologies, we need to go for the passive design. And that's mostly done with insulation and reducing our air permeability, which I'm sure will be talked about in the Passivhaus talk a bit later on. But there are other items such as building orientation and using your daylighting and using your solar gains and using solar shading to actually reduce the energy demand of your building. And this needs to be looked at a very early stage, stage 1, stage 2 REBA, to try and get the building as low energy demand as possible. Stage number 2 is putting in efficient system designs, reducing your energy consumption in the building. So to do this, we're looking at BMS control systems to actually control what's going on in the building, make sure things aren't left on and everything's running as efficiently as possible. It's the design of efficient plant and the actual design of the systems to make sure that the plant is running efficiently. Luminaire selection is obviously a big thing happening in a lot of buildings at the moment. It's phasing out the fluorescents and getting the LEDs in, because yet again, and reducing your energy consumption. Low and zero carbon technologies. So this is what might be changing with our grid decarbonisation. So the lower that the carbon emissions are happening on the grid will affect what technologies we're putting onto our buildings. So I've highlighted 3 here: there's biomass, district heating, and solar water. Highlighted these in orange because these are unlikely to be too affected by the change in grid emissions because they don't use electricity and they don't use gas. District heating is a tricky one to have on there because district heating obviously depends on the source of the heating and not actually the district system itself. These 3 technologies, we've got wind turbines, photovoltaic panels, and combined heat and power, I've put in red. Now, I've not put in red because they're going to become completely obsolete with the reducing the decarbonisation of the grid. However, they will become less effective in comparison to what they are at the moment. As at the moment, these are all electricity supplying, creating technologies. The technologies that will really benefit from the grid decarbonisation are air source heat pumps, ground source heat pumps. There's also marine source heat pumps, open water source heat pumps. Lots going on there. And these will benefit because these use electricity either from the grid or from your generating electricity products here to then create heat. And it was to see, when you see that the grid decarbonisation is happening and that electricity will have a much lower carbon emission, the first thoughts are, now we can install direct electric heating in all our houses. It's very low capital costs, it's easy to design, and it's easy to install. However, there are 2 big reasons why direct electric heating, such as just radiators that you stick on the wall, are not the way forward. The first one to do here is to do with primary energy factors. So a primary energy factor, which you can see here in this table, we've got for gas and electricity. Again, this will be changing with the SAP 2019. It is essentially much more energy intensive to generate electricity, get it to our houses than it is with gas, like substantially more. And this is something we need to factor in when we're calculating the carbon emissions. So as you can see at the moment, under SAP 2012, a gas boiler is massively favourable in regards to a CO2 emissions compared to any of these other electric technologies, direct electric being pretty dire in that situation. However, under SAP 2019, which as I said, may not be coming out till early next year, best case, the gas boiler is reducing its low carbon. It's not going to be as low carbon as it was in comparison to technologies such as heat pumps and the direct electricity. And as I said, the reason we can't put just direct electric in is because of this this PE factor. The other reason is cost. Grid electricity is still over 3 times more expensive than mains gas, and this does not show any signs of reducing over the next few years. In fact, it may even be going further up. And this is a big problem, because although the electricity has got lower carbon, because the price isn't changing, people just aren't seeing the benefits of putting it in. So under, apologies, I'll go back a slide. So the benefits there are, you see the heat pumps are massively going down in price, running costs this is, but your gas boilers are still going to be cheaper to run, even with the upcoming changes. Direct electricity heating costs an absolute fortune, and this is why we tend to stay away from it in any building designs we put in. Limitations. So I'm just going to cover firstly limitations of the Part L with our compliance, the limitations there. So the first one is the carbon emission factors, which is what we've been talking about. So the accuracy and source of these at the moment, it's not up to date. So we're not getting accurate compliance modelling being done. The next one here is unregulated emissions. So basically what I'm saying here is Part L does not account for process systems. So it doesn't account for kitchens, industrial, any plug-in electrical requirements and servers. The next one here, building profiles, how buildings are actually utilised compared to their simulations. And then in this graph here in the middle, what we can see is a Part L model, what it's measuring from a consumption perspective, and what is actually happening in the building when that's being measured on site. And there is a huge difference between the electrical loads on here. The cooling, the fans, and the lighting, there's a massive gap there between what is being modelled and what is actually happening on site. And as I said here with the unregulated emissions, these ones on top aren't even included in the Part L model. So the Part L model really isn't allowing for quite a large amount of the energy usage in our buildings. And the last two on here, which were actually discussed in the last set of Future Plymouth presentations, is the embodied carbon and the construction carbon, which just isn't included in the Part L simulation at all. There are also some practical limitations still to our building designs. The first one, and probably will always be a problem, is obviously human behaviour. And this is actually getting people to run the buildings efficiently, not leave the lights on. And as much as we can put controls in to help with this, there is always going to be a human factor behind that. Refurbishments is the next big one. Retrofitting these low carbon technologies into existing buildings is not cheap and it's not easy necessarily. And sometimes it's just not feasible. As much as we're saying heat pumps are the way forward, in a lot of commercial buildings, heat pumps just aren't feasible due to the grade of heat that you get. So we still will be for quite a few years looking at gas for a lot of our commercial builds until we find a way to actually fund these refurbishments. The next one there is cost, funding these projects. So as Peter covered in his talk, who is actually funding these projects? Do they actually care about the carbon emission of the building? Are they, in a lot of projects, maybe the capital team are not the same as the operations team, and there's no synergy there between the teams. And this is the big one, and I think this is what we've all been covering in these Future Plymouth talks. It's just the massive lack of drivers. The legal requirements are minimum. As I said, like Part L is our legal requirement, and it's not even accounting for huge amounts of energy being used in buildings. Lovely. So that was a bit negative. I'm going to end on hopefully a bit more of a positive note here. Starting off with this green industrial revolution, which is the points that the government came out with in November. So I've highlighted 3 of those in green, and this is all to do with grid decarbonisation. So further decarbonisation is happening with more offshore wind, advancing a nuclear clean energy source, and developing carbon capture technology, which is fantastic because obviously the lower that gets, the less we have to worry about the way we're using it in our homes and commercial buildings. The 3 that I've highlighted in orange there are still to do with buildings, but a little bit more specific. I'll come back to number 2. So number 7 here is making our homes and public buildings warmer and more energy efficient, with a target to install quite a large amount of heat pumps every year by 2028, which is fantastic. But until that SAP changes, it might be quite difficult to get the compliance there. Developing technologies, making London the global centre of green finance, so it all kind of plugs in together. Number 2 is really interesting, and this is the use of low carbon hydrogen production and using that in houses. They have been talking about this for many years, and as to whether it will actually happen and can actually be feasible is a completely different presentation on a completely different day, but it is very interesting and something to look into. I'm just going to finish here on zero carbon in use. So building physics guys in our office have done a little simulation to see how it's actually feasible to get to this zero carbon in use. So it's just a standard modelled community building here. And this is the building emission rate of the building as you would just a notional build. And then they've improved the building fabric, which is the first thing we'd be looking at, the orientation, how much glazing there is. As you can see, this is a pretty huge drop in the carbon emission rate just there. The next thing we'd look at is the energy efficiency of the services and the design of that, and that drops it down even further to 12.5. The next thing that was done here was to put air source heat pumps on the building, which again dropped it further, but it is worth noting that this is the biggest drop here, is those passive designs, and everything you do at the beginning of the building design is very key into the rest of the design. And the last thing you would do to get to your zero carbon in use is you could put some kind of electrical generating technology on to then feed the air source heat pumps, which then feeds the rest of the building. And it's a nice old cycle where you're not having to bring anything in from the outside, from the grid or the national gas. And then you can increase the amount of PV to get to the zero carbon and the energy performance certificate. What is worth noting here is with the decarbonisation of the grid, because this is all based on the current factors we're using, but with the decarbonisation of the grid, the amount of photovoltaic panels required to get to net zero will be heavily reduced. So it should become a lot cheaper and a lot easier to develop zero carbon buildings as the grid becomes more and more decarbonised. That's a pretty positive thing. And I'm just going to end on the kind of positive note there. Thank you. Thank you very much, Miles.
Thank you, Kate. And yeah, thanks for ending on a positive note there. If you have any questions for Kate or Peter, please stick to the end where you'll be able to ask them questions live. Peter's also put a really interesting question on the chat. Is a little challenge for you all without clicking the link. Nominate your most local high performance building in Plymouth. So have a think and put your answer in the chat there to see what we can get. Lastly, we have Andrew Nash from Kier Construction. And over to you, Andrew.
There we are. Right. Miles, are we there with a full screen? There we are.
Just might need to share your screen, Andrew, yeah.
Oh, I think, sorry. Share, there we are. Got my face on it the whole time. Right. There we are. Is that showing, Miles?
Brilliant, yeah, that's fine.
Great stuff, thank you very much. Yeah, thank you very much. My name's Andrew Ash, and I work for Kier Construction. And just with the question that got put on the chat a minute ago, just be mindful that my last job was Beckley Point. So just be mindful of what your comments are on that one. So please be nice. We had our challenges there. So yeah, I'm here to talk about sort of the Passivhaus building and the construction of Passivhaus. This is my second Passivhaus building that I've been part of. I've gone from one extreme to the other. My first was a 3-bed Passivhaus at South Devon College, which was used as a trial building. And then my second one is now the Passivhaus building at St Sidwell's Point, which will actually be the first building of its type in the UK. It's the third ever swimming pool that has been constructed. Two were originally constructed in Germany. One was a new build and one was a refurb. And I'm claiming this is actually probably as a world's first because we've got both the wet side of the swimming pool and also the dry side. So what we're going to sort of go through in regards of the talk is just an overview of the project, what is Passivhaus, and what we felt the base for success for achieving that would be, the progress to date, where we are with a few photos, how do we get the project team to succeed, the quality, culture change, so the sample mock-up we produced, airtightness, which has been talked about a couple of times, massively key to this project and quite scarily small, well, on this one, which I'll talk about in a bit, the accreditation and also any program implications that people sort of think with the Passivhaus there might be. So not only are we building the Passivhaus, we're actually building a really good looking leisure centre right in the city centre of Exeter. We've got a 25-metre competition or county competition swimming pool, a smaller trainer pool, and then we've got a gym, spa, saunas, all that kind of stuff. And for myself, actually really keen, it's one of the first building I've actually been part of building, I'll actually get to use. So I'm not only sort of the standards, I'm going to be as high quality as normal, but it's one that I will actually really enjoy using, which would be wonderful. We were talking about, Kate mentioned earlier about sort of the costs and things like that. We're very lucky with the client that we've got here, Exeter City Council. This is not their first dabble into Passivhaus. In fact, they've been producing Passivhaus houses for part of their housing stock for over 10 years now. So in fact, they actually handed over 10 Passivhaus houses today. So that's really important to have a client that's on board, because all the things we talk about in this, it doesn't take long. Everything's done correctly, and it takes the time to do it correctly. It takes the right cost to do things correctly. Over the years, we've sort of moved away from maybe 100% quality side of it, just because it's been pushed on program, on time, on monetary budget, things like that. Whereas this really gets back to a strong base of quality, really. So that's the project as it stands at the moment. So then, what is Passivhaus? So that statement there I've taken off the Passivhaus Institute in Germany's website. So it kind of really gives you a good idea of what Passivhaus is. So it's really the high level of occupant comforts. And when you've been inside a Passivhaus building, it's completely different feeling inside with triple glazing. The no air movement is it's a really calm environment, very steady environment to be inside of. It's very good for school environments, things like that, because of the quality of the air that's in there. It's an absolutely wonderful place to be. But one of the biggest outputs, as you can see there, the reduction in energy usage. There's just an example there of heating per unit of floor area, and you can see passive right down at 15 compared to the 150 for a modern sort of unit, which for the council not only means they're using less energy, they're actually, obviously it costs them quite a lot less. So yeah, another benefit for the client. But as we said, it needs to be a client that buys into this, because if you're a developer that's going to build, I don't know, a set of student accommodation with a view in 3 to 5 years to then sell it on, you know, the cost of this would maybe make that not as attractive. But if like Exeter City, you're building a building that you want to be climate resilient until 2080, this is exactly where you should be. So with the Passivhaus side of it, we looked at it as a team. What did it mean to us? And we came up with the 1, 2, 3, 4 sort of items there to sort of our strap line almost, kind of where every time we go back to, you get the design right, you get the quality right, you get the evidence right, and you get the culture right. And all of those items are from right at the beginning of the project all the way through to the end. And that's not just with the client, it's with the operatives on site. We talk a lot of times within the project about setting people up to succeed and not setting them up to fail. And that's setting, it's simple things. We would run at the beginning of the project to help with the design, right? We ran workshops right at the beginning, and actually the designers had to go using air tape, trying to tape a pipe that was really close to the ceiling. So they actually understood how difficult it was to do. So then we can actually look at the design of what we're putting together and then move that block of pipes or whatever it might be away from a wall or away from a ceiling to give someone actually an opportunity to get in there and actually put the air tape, the fire bat, whatever it might be, installed with every opportunity to do it correctly, not setting them up to fail because they physically couldn't get in there in the first place. A couple of pictures on site at the moment. Obviously it's dark all the time, it's dark at night and dark in the morning at the moment, but that's a couple of pictures of the outside of the building and facade. So the red material on the outside, that's a self-adhesive wrap-tight airline. So our airline, and something that's really important through the project, is to understand where your airline is, and I'll talk a little bit more about that later on. You can see the quality of what we're trying to install there. It's clean, it's crisp, it's all the lines look good. That gives you some confidence you're setting off in the right direction. And you can then see in the larger picture to the right hand side sort of the various stages of our facade installation there. There's nothing here different that you'd see on any building, but what the difference is the culture, the understanding, the quality, the hold points that we're trying to put in place. And again, you can see that there's different color tapes in that picture. You've got not only little tapes over the where the screw holes are, where the joints are, you've then got the different type of tape, air tape, which seals the different media. So from the cement board through to the concrete. So there's quite a lot of work that's gone in behind in the background in regards of what materials, what type of tapes, what the junctions. And as you can see with the Passivhaus, hasn't really hasn't changed the design of the building. We have a lead architect, Space and Place, who are more in regard, they're an architect for sports facilities, leisure centres. And then we also have Gale and Snowden, which they sit underneath our lead consultant, who are the Passivhaus architects. And they work in tandem really well. So you've got, they've worked together so well as a team to create this really stunning looking building. Internally inside of the building, I did mention we've got the swimming pool side of it. We've actually got a system called microfiltration, which is in that picture on the top left-hand side. That is, as opposed to having sand filtration, it's to clean the water. It's microfiltration, which is sort of pushed through high pressure, water's pushed through ceramic discs. So that was a battle that we had with the energy usage of pushing high pressure water through, obviously more energy usage, bigger motors, which was detrimental to the Passivhaus side of it. So we had to then look at other energy saving elsewhere to mitigate that. But because it's a swimming pool, we wanted the quality of the water to be absolutely spot on, which is what the microfiltration gives you. Just a stat, on average, a child in a swimming pool lesson will drink about a pint of water. So our current swimming pools that are sort of heavily chlorinated with chemicals, obviously you can imagine the children drinking that, and also the people are sort of with breathing sort of asthma, that's the word I was looking for, thank you. There's a layer of chemicals above the water, whereas with the microfiltration, you use a lot less chemicals, so it's actually cleaner, nicer water for everyone to swim in. So that was a balance with the Passivhaus and energy usage. Otherwise, in there, you can see we've got some fantastic glulam beam structure. That's the underside of the swimming pools. And also the learner swimming pool there, the smaller swimming pool, we started to do the rendering and tiling. So the project's moving on nicely. And then the bottom left-hand picture is some air taping detailing around the blockwork and masonry. And again, that's understanding your airtight line, because not only it's on the outside of our building, it then comes in through the masonry and goes back out again. So, and again, it's demystifying what Passivhaus means to the bricklayer, for example. All we're asking the bricklayer to do is, when he puts a block down with a mortar, is to fully fill his bed joints and fully fill it. No airlines that could be created. And then it's the same with a plasterer. When they're involved in the airline, there's nothing difficult for them to do. All we're asking them to do is plaster from the floor to the ceiling to the 2 columns. That's what they've been paid to do. But over the years, people have reduced that plastering requirement, because you don't need to plaster to the ceilings, because the air tightness line isn't there. But with Passivhaus, they've just got to understand that it is a bit different, and they have to not just do what they've done normally, understand exactly where they've got to plaster to and why. And that's part of the education which we'll talk about in a bit. So in regards to success for the project team, early engagement's really, really important. So we ran, like I say, design workshops, which were absolutely fantastic. It really pushed out some really good answers, really good questions came out of that early engagement and design with the designers. We were lucky with this project. Well, I say lucky, it was well managed. We had a two-stage tender. So we had opportunity within that to sit down with our key supply chain members that are relevant for the air tightness and Passivhaus, and work with them to demystify what Passivhaus meant to them. This meant that they weren't going to put a risk pot of money against what Passivhaus meant. We made sure they understood exactly what they need to do and what their requirements are. And if they achieve that, we will achieve Passivhaus. And that was again, a really well-planned sort of set of meetings that everyone then got buy-in. And then all of a sudden we started to become a team because everyone was talking about it. yeah, the selection of design is based on relevant experience and competency. There's lots of passive houses being built, and we've got some really good supply chain down here with relevant experience and competency. But we felt we needed to do a few more training sessions to get everyone up to speed on the same page, because people do have relevant different experiences, and also throwing the leisure centre side of it. Again, people got different experiences with that. So we sort of created almost a leveler playing field as we could. Yeah, I've talked about the passive house designer within the sort of our lead design team. And then overview of the specific design requirements in regards of air tightness. Building biology is another thing we've actually, as part of this project. So again, some of the building biology requirements do conflict slightly with the passive house in regards of air tightness and having open windows for building biology, but obviously air tightness for passive house. So in regards of supply chain success, we need to raise a standard. We felt what a good example would be to sort of say, we really understand safety and everyone on site understands safety. We need to get quality to the same standards as safety. So we got our supply chain, and we felt that we needed to not just tell them how to do it, but why they need to do it. So that picture behind is the lift base, and you can see it looks like a cake almost. The quality is absolutely spot on. So we educated our ground workers to why they needed to make sure their insulation is no more than a 3 mil gap. The loss of the U value for doing that, and they understood. Then all of a sudden they were thinking differently. They were engaging with us on site to understand how they could do it better. How a pile coming through the ground it's all sort of misshapen. How on earth do you get a bit of 300 mil insulation wrapped around that pile with no more than a 3 mil gap? And they actually bought into it and came up with some really, really good solutions about how to resolve some of those issues. And they really enjoyed it. It was really refreshing for us to go out onto site and be able to talk about quality and ask someone about how they've done that, you know, and they understood why. So they got really, really good buy-in from our supply chain. And that did create a culture of pride, as it says there. So to help with the education side for not just our design team, but also for our supply chain, we ran a series of inductions for each of the trades. So we kind of called it as a passive house passport, kind of where we sort of termed it. So we ran one specifically for the groundworks, so they can understand where they were. We've just recently done a building envelope induction. So again, they all have the base of passive house to understand what it's about, but we also then go into a little bit more detail for the specifics of each trade or area. And then this is one of the outputs from it. Again, it's the same picture because, as I say, it's one of my favourite pictures of the lift that you could get. But it's the groundwork supervisor or manager saying, just like putting that on the pride of that. And I think there was thousands and thousands of comments and well dones on quality and attention to detail. And that's what's been a really good output. And one of the other words we use from this is a ripple effect. So they now know, as a subcontractor, as a supply chain, as an operative, how to install insulation to the highest of qualities. So they'll take that to a non-passive house site and then apply the same. And for me, that's what I've done with Passive House when I did my Passive House 2006, or whenever it was, maybe later. When I did it then, and I've taken those things to other projects as well. So it is a really good ripple effect and upskilling of everyone. This is our one of our quality flow diagrams. This is probably the most complex one, so I thought I'd put it on there. But we spend a lot of time with our quality. One thing we realised is people don't understand on a site level how do you produce the inspection and test plans, how do you produce a check sheet, and which order they all come in. So we spent a lot of time with our operatives on site, but also supply chain, explaining that you pick the design up, you pick the specification up, and then from that you create your inspection and test plan, and then from your inspection and test plan you create your check sheets. Ask anyone about health and safety and say, can you give me a risk assessment method statement? No problems at all, they all understand that. So that's where we was mentioned before about getting the quality and the safety on the same par of understanding. We're in that place now with understanding of how to produce check sheets, inspection and test plans, and what they mean. So again, onto site, a few pictures here of some little things we've kind of started to do here and pick up. I love that on the right hand side, the QA accepted. So what that is, that's obviously we've made some custom made stickers there. We put on, and people sign their work off. You're putting, like back in the day, when you see go up into a roof of an old building and the carpenter's chiseled his name in the eave sort of thing. We've kind of tried to do that a little bit with the QA acceptance thing. So when they've completed their work, the subcontractor who's been working on that elevation of Raptitis says there, puts a sticker on, we come through and sign it off. Just to get that pride that they've been part of it, they put their name to it, they've actually signed that they're happy to pass that over as a completed part of the building. Then on the other side, on the left-hand side, that's kind of lessons learned, really. So that's an air tape that's on the floor. Obviously, it's a construction site and people move things around, pallets, mutes and things. We just put a timber down there just to protect it, stop that tape being damaged. Okay, things happen on construction sites, a reality, but if we can stop 90% of it, when we come to do that final check, we've got a lot less to worry about if there's any repairs to do. So one of the things we did on site, which we've got so much out of, is we created a mock-up panel, 3 meters by 3 meter mock-up panel, which actually we air tested. So we've done our first air test on the building makeup. What was quite interesting, there was some Passivhaus accredited parts that weren't as airtight as we maybe thought they might be. So we've gone back and got them rejigged and changed. We could have a look at if the lads, or if a operative doesn't put the screws in exactly straight to the material, or they drill one out, or they put one at a bit of an angle, what does that mean for our air tightness? If they do that 100 times over our facade, would that mean our air tightness would fail? What capacity have we got? What capacity? What's our zero as a building? So is the design so good that the building is airtight, or does the design not quite work? And this is a really good opportunity for us to get some education, lessons learned, all those kind of buzzwords, just to see what we were doing. And it meant that we weren't learning on site, we were learning in our mock-up zone before we've even started. So it gave us opportunity to throw some water on the wall. How does it stick? Does it work still? All these kind of things we could have a trial first. So that was one of the biggest things that I think was a benefit for us. And again, these are some really good lessons that, again, what's one of the funny things, you look at old pictures of site and you think, oh yeah, that's really good quality, well done. But now I look at things so differently. So examples there, you've got a crushed insulation on the left-hand side, and then a good insulation on the right-hand side. How many times have we been on site and looked at A and think, oh, that's not a problem? But you realise, you look at the difference that you make with crushed insulation, you times that by 10,000, 20,000 fixings over the facade. All of a sudden, that thermal bridge effect is just absolutely massive. So these are the really kind of things that's been absolutely fantastic learning opportunities for everyone within the project. But that said, even then, with all that, there are still mistakes happen on site. So part of our quality control is before anything gets signed off, closed up, we go over it absolutely fine-tooth comb, because we don't have capacity to have mistakes in this project. It is perfect, is what the air tightness line, the thermal, all those things, it is perfect. That's what we're striving for. So areas like this, we need to, we review, we find out why it's happened, who did it. And it's a no blame culture. We don't go around screaming at people and saying, what on earth are you doing? We try and educate them. So if they see a mistake somewhere else or someone else has then done, they can talk to them about why you shouldn't do that, or if there's an error. So it's all of a sudden you've got going from having 12 Kier managers walking around site looking at quality to 120 people walking around site understanding what you're trying to achieve and understanding the quality. So air loss and air tightness, some scary figures on there, as you probably can see. That's not figures that we're normally used to seeing. We normally see 10, 5s, maybe 3 if it's a good building. We're pretty much getting, like I say, an airtight building. And it goes back to one of the points Kate made. We can build this thing perfectly, but as soon as you put humans involved in it, the doors get open, the windows get open, things get propped. So all of those lessons learned, we have to then pass on to the end user to understand how to manage this building, how to manage the microfiltration, as well as the passive house side of it, the building biology side of it. So there's a lot of education that we need to put in for the end user of this building. But yeah, so you can see that tiny little red dot. That's the size, 350 millimeters by 350 millimeters. That is the amount of air leakage over that whole building's facade that equates to those figures. So yeah, really a fantastically technically accurate challenge for us to achieve. I'll just move on to the Passivhaus Evidence Manager. It's probably worth talking. We've got sort of two specific roles in this project that are different than normal. One would be we have nominated a air tightness manager, and they manage the air tightness because it's such a critical part of achieving Passivhaus. And we've also got a Passivhaus Evidence Manager, and their role is to literally, exactly as it says, evidence manage all of the information. And there's quite a bit to get hold of, to be fair. So we have photographs of wall slab, roof junctions and insulation, windows and doors, thermal bridges, air tightness, ventilation, hot water and heating pipework, electric systems, and also the pool treatment. So I've got two photos there, and that's kind of the example of the heating pipework picture showing the thickness of the insulation, which we can evidence, then also it finished installed as well. And you imagine we've got probably a 20 to 40,000 photos of different stages of the project. We've made a register so we can see where we are, red, amber, green register to see. We've listed out every single photo we need to take, so we can just keep track of where we are, because obviously we don't want to go back and have to open up insulation if we don't have to show what we've installed. So yeah, it's quite a beast, the evidence manager. But again, we should be doing this anyway. We should be evidencing that we've got the right insulation. We should be doing photos like this. It shows we've got the right thickness of insulation, in the right pile cap location, with the right type of rebar, with the right cement in there, and a nice finished picture at the end. We should be doing this anywhere. There's nothing wrong. There's nothing different than we should be doing anyway. For various reasons, over time things get slightly diluted on it, but this is where we should be. And to be fair, we're really enjoying the quality output that we're producing here. So I think I've got a few items on program here, because it's one thing that always gets picked up. It's one of those things for me, the program doesn't take longer. The program takes the right amount of time. What over years has happened, the programs and client pressure has squeezed our programs not to allow us the suitable time to create inspection test plans, to have hold points, to understand it, to build it to the right quality, speed, time, the right materials. So yeah, there's nothing really, I think, with the program. It doesn't, yes, it adds time from what we'd expect normally, but this isn't a normal building. This is how it should be done almost. And you can't really squeeze a program. It's got to be done at the right time, at the right speed, inspected, tested, and checked. There's no two ways about it, really. So yeah, that's kind of really, for me, a bit of a chat over on that. It's quite a lot of information on site, and hopefully we'll be able to do a few more of these sort of presentations over time, but that's kind of a high level, quickly, what it's like to have a Passivhaus project.
Thank you very much, Andrew. That was really interesting. Some great stuff there. Thank you. I look forward to seeing the building when it's done.
Oh yeah, definitely.
How far has it got to its complete?
We'll be completing the summertime. So yeah, but at the moment we're getting the facade complete. We've got tiles going down at the moment. So then when we come back in the new year, we've got quite a large commissioning period because of the Passivhaus, and we have to be quite precious about that commissioning period, not to affect the Passivhaus side of it. It's a fairly stringent process, so which is good again, because it's done as it should do, and we'll stop our building works, will be complete, and then we test it. So yeah, we should be looking forward to be swimming and using the gym and spa in the summer.
Nice, brilliant. Thanks very much, Andrew.
Not a problem.
Before we go to our Q&A, I just want to thank our lead sponsors and partners of this programme, which have made it all possible. I just want to say a big thank you to Plymouth City Council, the RIBA, the Sustainability Hub Low Carbon Devon project, the University of Plymouth, buildingplymouth.co.uk, the European Union, Constructing Excellence Plymouth Club, Her Majesty's Government, and Stride to Glow. And thank you all so much. And also thanks to all our partners as well. There's so many to mention, but they're all on our website, futureplymouth.co.uk, futureplymouth2030.co.uk, sorry. Please, if you have any questions for our panel, please raise your hand now. Just got one from Matt. Matt, ask away.
Yeah, hi. It's thank you to everybody. Really interesting presentation. It's a question for Andrew, or really just interesting observation. Your comment about program versus the cost benefit to Exeter City Council in terms of the energy saving. It just makes me think that the challenge we have is to get clients to understand, as you say, demystify Passivhaus, that extra bit of effort in program, the dividends it pays further down the track is worth that investment. And it's, I suppose, really it's about having the track record of completed projects where you can then demonstrate, you know, okay, it might take us another month. For residential, it might mean a month's delay in going to market, but actually what you're going to gain down the line, it makes it worthwhile. So really just I'm just sharing my thoughts really, but very interesting presentation, thank you. And also the skills issues, and I love the way you've got all the contractors to buy in, and the quality of workmanship. You're right, we should be doing that. It should be the norm, and it used to be the norm. So thank you.
No, Matthew, thank you very much. Exactly that. It's, when I've gone and done sort of Passivhaus talks elsewhere, it's almost embarrassing talking to people that aren't in the construction industry when you're saying about what we're saying so amazing and so brilliant about Passivhaus. All we're doing is designing it well and installing what we've been asked to design with the right materials. And it's yeah, I think I've really enjoyed it. And also for the client, they get not only the energy usage, but they get a better building. I feel the quality and the whole points, the materials we're using is so much better. So there are so many benefits to it's the feeling inside of a building. A lot of, like I say, schools really benefit from how it feels inside. It's a calm environment. So it's this is a really important building for Passivhaus globally, really. Because they want to show what it can do and what sort of benefits, like I say, the energy side is the Passivhaus sort of scientists are looking at, but also the softer side of how it makes people feel inside of the building. But it is a client-led at the start, that's for sure.
Thanks, Andrew. Thanks for your question, Matthew. Peter, we've had a few suggestions for the most high performance building in Plymouth.
Yeah, I've been writing him down.
Beckley Point, you'll be pleased to know, Andrew. Yeah. Genesis building with the living walls, lovely building. Portland Square, Sally's house. What are the most economically friendly buildings, would you say?
Difficult question. What is high performance, in my view, is really dependent on where you put the emphasis. So there's so many aspects to look at, and I think these are all good examples. And some of them I recognize, some of them I need to have a look at. So TR2, for instance, I need to check back what really is on there. I haven't been there, so good stuff.
Thank you. We have a question come through. Generally, what control is there on supermarket chilled areas? Summer last year, it was 23 degrees outside and 15 degrees inside Tesco in St George's Street. In December, the chilled area of M&S was 4 degrees different in the chilled area at the back of the store, with hot air blowing down at one end and the aircon at the other aisle. Also very uncomfortable customers. Surely it'd be better all round to enclose the chilled area like they do in Canada. What would you guys say about that?
Who are you asking? Is that me or?
Any of you really? I was probably you, actually, Peter. Yeah.
Yeah. Well, the difference between Northern America and the UK is an interesting one. There's cultural things in there as well, and that goes back to that whole complexity of where we put the emphasis and what we think is more important. Things like the Tesco with conflicting systems, I think that is always one that you want to prevent from happening, and it is the same with ventilation and heating systems battling each other, or in control systems that are not good. That's all part of ironing out the first level, right? And then you go deeper and deeper and deeper, and you end up with Matthew's talks about or Andrew's talks just recently, where you can go the different layers and have to go through all the stakeholders and make sure they all understand what you're trying to achieve and buy into that. And at one point, it's a technical exercise in making sure that everybody understands the technical thing, that it is not a good idea to have an air conditioner at one end and a chiller at the other end, battling each other. But at some point, it also goes down to the deeper data and understanding why that is important and why we need to do that.
Thank you, Peter.
And that comes back to things like even the occupant behavior and how we deal with COVID, right? I mean,
yeah, of course. Sarah Lee?
Hi, can you see me?
Yes.
Hello. Hi everyone. Thank you for your attendance today, and thank you to our speakers. That was really interesting. And I think the message that I've been getting loud and clear is that it's about the education. We need the education to demystify, we keep using that word, but just to help people to understand what these different standards and categories mean, and why our clients or procurers, developers, procurers of buildings need to be asking for these things and insisting that those standards are achieved through the design and the construction. And as Andrew said, they're lucky with Exeter City Council. They seem to have a very enlightened client who are happy to accept a bit of extra time in the programme or the development and the cost to achieve that. I met with one of the directors last year when we were talking about how to decarbonise Devon, which is where this webinar series really came from. And he kind of joked and he said, yeah, it is costing us a little bit extra money, but the investment's clear. In the long term, these buildings aren't going to cost us money to run. So it's not just being done for a climate benefit. I mean, it is going to help them out financially in the long term as well. So there are other benefits to this as well. I wanted to go back to one of Kate's points, actually. Kate, you mentioned about Boris's 10-point plan. I was quite encouraged when that was released in November. Obviously, we've been focusing on coronavirus this year, rightly so. It's been the main issue that we've had to deal with, most immediate, most life-threatening issue. But I was quite glad that they've obviously started talking about this green industrial revolution and this 10-point plan. I wondered if you could talk a little bit more about that. Why you made a comment about hydrogen. Obviously, they're talking about hydrogen being our saviour. I had my gas boiler serviced the other day, and the engineer was saying to me, that we're not going to be getting rid of gas boilers and the gas network necessarily. They're talking about converting it for hydrogen. I wondered if there was any more information you could just share with us on that.
I think the main thing you need to consider there is it needs to be low carbon hydrogen, because there's no point in just using hydrogen because it's actually very energy intensive to create hydrogen in the first place. So the amount of electricity you need, but obviously the idea is that we'd be making this hydrogen from renewable sources, so from your wind, from your other sources essentially. But we've got to factor in at the moment that everything is going electrical. So our vehicles are meant to be all electrical by 2030. Our buildings are using more electricity. We're charging more appliances like laptops, phones, etc. And it's whether the grid can actually handle that at the moment. The amount of renewables they're going to have to plug into the grid to handle that is huge. And if they're adding on top of that, using renewables to create hydrogen, there's just not enough there at the moment. And it's whether there'll ever be enough to create all of that. Personally, don't think hydrogen is going to happen for a long while, if it even does, because electricity is in a pretty good place at the moment, and we can create pretty good heat from electricity. So the need for hydrogen isn't necessarily there.
Thanks. Sorry, I'm on mute. And another question I had, sorry, going back to, well, all of you really. I mean, obviously we talked about the building regulations. Is there a need for the government to actually just increase the building regulations? It seems that some people moan about trying to achieve building regs as a basic minimum standard, but it seems that standard just isn't high enough. we need to increase it nationally? Is it that there are, as Peter highlighted, all these different terminologies and names and categories, standards that are out there if people choose to use them, but do we need to just make that, pick one of them and Passivhaus, whatever it is, and stick with it, make that statutory? That's a bit of a question for all of you, really.
One thing I would answer to that, and taking on the view that energy is one of the driving factors here in terms of performance-based regulations. My experience is that the regulations are fine, but we need more enforcement. And the way to do that is you ask people to do a calculation to predict your energy efficiency of a building, but the link between building control and actually going out on site and saying what is in this calculation is actually done on site. That was a problem in the Netherlands 15 years ago, and that is still there. It is so easy to do your calculation with triple glazing and then say, you know, actually install double glazing, that is cheaper. On that level is where you need to make sure that what is in the calculation is really there on the site. And I think that's where I would start.
Definitely. I think that, yeah, you're definitely right there. There needs to be more monitoring post-build to see what these buildings are actually achieving. Because we can say an as-built, as-designed building is achieving all this amazing carbon, but in reality, what are we actually getting? And there's very little monitoring of occupied buildings to actually give us that information.
Yeah, I think for me, that's one of the joys of Passivhaus. Especially this one, they're going to stick with it afterwards and tweak the controls, the BMS, to make sure it's as efficient. So you look at the energy usage of the swimming pool when there's 100 people in there, 20 people in there, and same with the gym, all that kind of stuff. They will then play with the system to make it as efficient as they can. So that's really a positive outcome. It's not just we build it, yeah, we've ticked all the boxes, we built it right. It's then checked, and hopefully we'll improve on what was modelled originally.
Thanks, guys. We've had a question come through from Christopher. This is for the panel. In terms of Passivhaus, is there a trade-off between design for deconstruction / disassembly? What is the environmental long-term impact of using single-use tape, etc.? Can Passivhaus examples be completely deconstructed and materials reused or recycled at end of life? Yeah, I mean, there's nothing here different than we'd use on a normal job. It's just what's being done is just so we'd have to seal all the joints anyway on a normal construction site. Airtightness is not something that's new. So in regards to this, yes, you've got a concrete frame, you've got a timber roof over the swimming pool, and you've got a SFS facade, which is exactly the same that you see on the majority of jobs being built at the moment. So yes, they can be deconstructed just as easily. Well, actually, it's probably more difficult to build them well. But yeah, they can be just as easily deconstructed. And yeah, in regards to the single-use tapes, that is one of as with everything, you can't get everything right. There is a payoff with Passivhaus. Passivhaus looks at energy. It doesn't look at embodied energy within, say, the concrete structure we've used. It's purely on the U values of materials. So it's from a very scientific point, sort of physicist point of view. And so, yeah, there is a balance between, say, where your BREEAM would look at your recycled aggregates and things. There isn't quite that focus with Passivhaus. It's purely energy usage straight up. So nothing's perfect. Thanks, Andrew. Question from Mark. Electrical heating put into heat pumps will mean 3 to 6 kilowatts of energy, of heat, for every kilowatt electricity. Hydrogen, I think, needs a new gas network as it causes problems with the current pipework and is difficult to contain. Is this true? And how can he turn his Edwardian house into a Passivhaus?
Just on that, the first bit there, I'm sure we'll be able to cover the other Passivhaus bit. Yeah, you're absolutely right. It is a lot more efficient and it is a lot more practical at the moment to go forward with this electrical heating with the heat pumps because of how efficient they are. And as I was saying earlier, it's extremely energy intensive to actually create hydrogen in the first place. So it's not necessarily practical. And then you add on top problems with the pipework networks, transmission losses, delivery losses, etc. And hydrogen boilers, which aren't really even in, circulation yet. So there's a lot of, hydrogen's always been this buzzword, and it's always been something that people want to go for, but it's been like that for years, and it's not really happening because we've got other better technologies that we can use. All I will say is heat pumps do create quite a low grade temperature, and there are applications, especially in commercial builds, where a much higher grade temperature is required, which will require gas or hydrogen, but it is a very small percentage of buildings that would actually require that high grade heat.
Thanks, Kate.
Yes, in regards of a retrofit passive house, everything, obviously you've got the structure to start with, but the PHI Institute website is actually really good. It's a really good source of information, and there's an old stone house that's been done, Victorian terraces has been done. If they are serious about that kind of, that's something they'll be looking into. Obviously, we use warm, low energy consultants. That's Sally. She's they are the biggest accreditor of passive house in this country, and they are a really good base to start with. But yeah, passive house website first off as well would be the way to look at it, because they will give you techniques, details, cold bridging. But you will have a bit of a clash with grade 1 probably, or grade 2 listed Edwardian windows that may be a little bit rattly and a bit windy. So then you'll have to look at doing something inside of that. So yeah, as with everything, there's a balance and a payoff.
Brilliant. Thanks, Andrew. Hope that helps, Mark. If anyone else has any other questions, please raise your hand now. Whilst you're doing that, I'll just remind you of the next webinar. So put it in your diaries. It's for the 13th of January. And it's technology and innovation. And again, it'll be at the same time at 4 o'clock till 6. And we'll have Peter Kidd from the Southwest Infrastructure Partnership, who will talk about infrastructure and our future energy needs generally. Dr. Zaki Hamid and Johnny Blore from the University of Plymouth will discuss power and electronics. And then we'll have Alistair McPherson from Plymouth Energy Community, who will explain the rationale for community-owned energy infrastructure and solutions. So a really good webinar to look forward to after Christmas. So that's on 13th of Jan. So please register on our website, futureplymouth2030.co.uk, and put it in your diaries. Do we have any more questions at all for the panel before we go? I don't think we do. So thank you so much, guys. Thank you to Kate, Peter and Andrew for their time, and for a really interesting session. And just leaves me to say have a wonderful Christmas and the new year, and we'll see you all next year for the next webinar. Thank you very much.
Lovely. Thank you, Miles.
Bye-bye.